Awesome. So thank you everyone for coming to a testing talk right before lunch. I know that's like a pretty hard decision, and I really appreciate that you chose to come to a software testing talk right before lunch. You're all excellent people in my books. I don't have enough Bud Light Lime for all of you, but if you come visit me in San Francisco, we'll get some Bud Light Lime or something non-alcoholic. Not that Bud Light Lime is particularly alcoholic. So just in case you came to the wrong room and you didn't actually want to come to a software testing talk, this is Beyond Parallelize and Collect, effective testing for Spark programs. My name is Holden. I'm a software engineer at IBM in the Spark Technology Center in San Francisco. And just like almost every company at this conference, we are hiring. And if you want to come work with me and wear fuzzy hats, give me a shout. The fuzzy hats are optional, but definitely strongly encouraged, except I'm the only one that wears them. So yeah. My preferred pronouns are she or her, in case anyone's wondering. It's tattooed on my wrist. If you forget, you can just look there. Try not to fuck it up. Previously, I worked at Alpine, Databricks, Google, Foursquare, and Amazon. And I've done sort of like a lot of things in this big data sort of space, a lot of recommendation stuff. And I think testing's really important for these big data things. I'm a co-author of Learning Spark, as well as Fast Data Processing with Spark. And I'm also co-writing another book with Rachel. Is Rachel here right now? Okay. Well, anyways, she's at this conference somewhere, and she was part of a talk yesterday that was also awesome. So I hope you saw that and have already given us your email address to spam you. If not, you should do it now. I'm on Twitter. You can follow me for tweets occasionally about Spark, mostly complaints about American healthcare as a Canadian who just really doesn't understand what the hell's going on. The slides from this talk and most of my previous talks are up on SlideShare. So if you do want to take a picture of a slide, this is probably the one you want to take a picture of. You don't have to, though, no pressure. If you want to connect with me in sort of a more business numbers way and less pictures of cats, you can find me on LinkedIn. And if you're interested in learning more about Spark and you like my presentation style for whatever crazy reason, I've got a bunch of videos, and they're all free up on YouTube, and there's a bit.ly link at the bottom of the slide as well. So I'm going to sort of talk about who I hope you all are. Hopefully I'm not too far off, and if I see a lot of blank faces, we'll adjust the talk as I go. I'm going to do a bit of preaching to the choir. You came to a testing talk, so I probably don't need to convince you all that thoroughly to test software, but I'm still going to do it a bit anyways because it's just a habit. We'll look at writing really simple unit tests in Spark with Parallelize and Collect really quickly, just in case someone maybe hasn't been testing their code as much as they should. A little bit of judgment, but not that much. Then we'll sort of move on to the things that are more fun. How to write tests where it's too big for a single machine, what sort of considerations we need for writing tests for streaming and data sets and all those things. And I promise there will be a picture of at least one panda and at least one cat. And I over-deliver on one of those, possibly both. And then I'll also talk about sort of where some of the testing stuff is going from sort of my point of view. Most of the integration stuff is sort of in the future work area, because integration testing with Spark is really challenging right now to set up properly. And so there's some things, and we'll talk about how to sort of get to them, but there's not like a really easy solution I can just tell you to go and put on your Jenkins server and have fun. And some of the future work might even happen. Unlike most future work sections, I actually continue to work on testing stuff because it's something I care about. So I'm hoping you're all really nice people. The front row has done a great job of laughing at my corny jokes, so that's great. That's a good sign. If you're not nice people, just pretend to be nice people for the rest of the talk. I don't want to find out. If you don't like silly pictures, you need to ignore the top right-hand corner of my slides. Other than that, that's where most of the silly pictures are. How many people are familiar with Apache Spark? It's day 2, so like, okay, oh, thank God. Okay. So if you're maybe watching a recorded version of this and you're not in the room and you're not familiar with Apache Spark, this talk does assume that you know Spark, and just go check out one of the very many great intro resources, buy my book because I like money, or watch Paco's videos because Paco also likes money and does great videos. How many people are developing primarily in R? Okay, so for those 2 people, we can hang out later, but there's not really a lot in this talk for you. All of the tools are sort of more JVM and Python focused, but the same general techniques will work. It's just the tooling isn't there. Cool. So why should we test? It makes us a better person. Coming to this talk was a good start. It makes you a good person for coming to a testing talk. It saves us money. And by that, mostly I mean it keeps us from losing money. Untested software is pretty frequently a good way to lose a lot of money if your software is important. And if it's not, it's a really good way to get fired when your boss finds out it's not important that you're doing your job. If we were on the West Coast, I wouldn't say it saves us money. I'd say it saves us users because we don't have any money on the West Coast. We just have users. But since I'm here in New York, we're going to talk about dollars. AWS is also pretty expensive, and just like the earlier we can catch our bugs, the less expensive it is to fix them. If we have to wait for an entire run of our job, that could be 8 hours, and we've burned 8 hours of compute time. And even if it's not coming directly out of our budget, it's still money that's being wasted or compute resources that are being wasted. And honestly, we all hate long dev cycles, right? No one goes, man, I really wish it took me an extra hour for my code to compile, or my test suite finishes way too quickly. That's not a thing, right? So we want to get our tests to be going really fast. But really, this is to give you flashbacks to your QA internships and remind you that you don't want to get on board the fail boat. The fail boat is a very sad boat, and your code doesn't compile anymore. Another really good reason to test is a lot of people are actually deploying their Spark models automatically to production. How many people do that in the room, actually? I'm really curious. Is that just the crazy people that answered my survey? Okay, cool. So in this room, there's more people. People are more cautious than the crazy people that answered my survey, who a third of them were deploying their models automatically to production. But if you're doing that, you really need good tests, right? I've accidentally pushed out models which have done terrible recommendations for people because we didn't have really good tests to ensure that our code was correct, and we made really bad recommendations. And I still had a job, but it was a really awkward meeting the day after. You don't want that meeting. The other one is most people have encountered problems with their Spark jobs. Testing won't stop all of these problems, but it'll let us catch them sooner. Most people weren't really sure what serious meant. I assume that all of that 41.7% were I still had a job, it can't have been that bad. And the other half has just been lucky or isn't using it in production. That's sort of my assumption, but maybe I'm wrong. And the 8.3%, the virtual hugs, it gets better. So why don't we test? We don't test because it's too much work. And I think this is especially true with Spark and other distributed systems like it, right? We all know that we should be testing, but it's taking too much time, and we want to just get on with the fun parts of our job. And I think the solution to this is we can't really necessarily make testing a lot of fun, but at least we can make it fast and less painful so that the time that we do have to spend testing our code doesn't take that long, and we can go and get beers with our friends or Bud Light Lime. I really like Bud Light Lime. Or pet our cats, whatever it is that makes us happy. Okay, so that's my preaching to the choir, convincing you to test sort of phase. We're going to go and get down to work, just like this cat is taking a really delightful nap. So really simple Spark tests. We can make them ourselves really easily, right? We can just make this transient variable of a Spark context. We just need to remember to create it at the start of each one of our tests. And then tearing it down becomes a little bit more tricky because we need to clear a random property so that it doesn't respawn on the same port in our next test immediately. But it's not all that much work, right? Setting up a Spark test, this is really simple. On the other hand, we're testing something that we're intending to work on big data with about 3 elements. Some of you may see some problems. Sometimes problems don't show up at 3 elements that show up pretty quickly at hundreds of thousands. And I'm not saying you shouldn't have these kinds of tests. I'm saying we need more than these kinds of tests. I'm also saying that was only one slide of boilerplate code, but I don't even like the one slide of boilerplate code. We should use a library to handle that boilerplate code for us, and maybe we can even get a library that's going to do more. So there's a bunch of different libraries, and if you want to take a picture of the slide, that's cool too. And these are just sort of some different tools around making Spark tests. There's Spark Testing Base, and that's a project I'm involved in. So I naturally think it's pretty cool. There's SS Check, which is also a really awesome project. And we'll talk more about sort of the kinds of tests we can make with it. And then there's some really interesting things out of Databricks. They're more focused sort of around testing Spark itself, but I found that they're also not too difficult to hijack and use for my own ends. So if you're like, oh, I need some integration testing, looking at the Databricks stuff, which does a lot of really cool sort of Dockerized stuff, can be a really good place to get started. And Spark Validator, which is the last one, I am involved with. You can see my name is in the URL, but it's a really early stage project, and if you use it in production, I really hope you don't know where I live. And don't page me. I'm not going to answer your page. So we can get rid of our slide of boilerplate code, but that's not really all that exciting. We can write our nice simple test like this. But I think this is good because this sort of sets a baseline of what the rest of our tests can look like for the other parts of testing Spark. So let's go and do something awesome. Right, so our thing is we need to test on more than just 3 elements, right? It's not a good big data test if it's only 3 elements. Our pool is going to overflow, and we're going to have a really sad time if we try and use Parallelize and collect to test these really big things. The first step that we sort of need to do is figure out if 2 things are equal, right? Like if we look here, that's the very last step is we collect it and we compare it with the expected value. So we need to, in a distributed way, see if 2 large RDDs are equal, or data frames. And some of you who may have spent too much time in your graph theory class or whatever may be going, I know, there's some distributed set operations inside of Spark. I'm going to use those. That's going to be great. And they're actually pretty cool. They don't work very well in practice, but they give us a good starting point of sort of how we might want to think about comparing 2 large data sets for equality. They don't handle floating point numbers. Those damn floating point numbers keep showing up everywhere. It's tricky hobbits. And they don't handle duplicates very well, right? Our RDDs aren't actually sets. We don't have to have unique elements in them. And if your RDD is a set, the set comparisons could actually be okay. But on the other hand, if you think that Coffee Coffee Panda is not the same thing as Panda Coffee, and someone stole your coffee, then you don't want to use distributed set operations to compare your 2 RDDs. Instead, we can sort of do zip if our RDDs happen to have the same partitioner. And that would work really well if we hadn't done a whole bunch of transformations to our RDD, and probably we have no idea what the partitioner is anymore. So this is our first attempt, and it falls promptly flat on its face, but it's a good start, right? And our next attempt, I don't actually need you to read and understand this code, but I just want you to understand that there's these different compare functions that we can provide that will work for comparing RDDs of well beyond the scope of a single machine. And so we can use cogroup, and we can shuffle our data around, and then we can compare it that way. And that works pretty well. It doesn't work very well for floating point numbers, right? Since the cogroup with floating point, the hashes aren't going to make sense. And so we need to do something else, and we need to actually do this weird zip with index trick. But this is a really simple comparison for some data, and it's going to work. So hopefully you trust me that there's this RDD comparisons object that we can use. It's not inside of Spark, but we can go and get it, and we can bring it into our program, and we can use it for our distributed tests. But now we need to actually get some data for our tests to run on. We can't really use Parallelize because that's a single machine, and we also need to come up with enough data that's actually useful, right? Coming up with a few strings to test and the example results is really easy, but I don't want to sit down and manually work through a gigabyte of sample data for my golden set for my tests. That's just not going to be a lot of fun. If I have a slow local version that I already know works, that can be a really good way to come up with some golden data to test against. But if I don't have something like that, I need another technique entirely. One option is just sampling your production data, and you can see it's pretty common. Some people even just use their entire production data. I assume they're working with kilobytes of data, and they're just optimistically using Spark because they're going to be the next big thing, and their user graph is going to get huge. And if you're like that, that's fine. Just use your entire data. It's okay. You don't have to sample it. But you can be one of the cool kids and still sample your data. But like if we don't have really easy test data available to us, what's our other option? And our other option is doing something called property checking. How many people here are familiar with like quick check, Scala check, and that sort of property checking stuff? So that's a good number of people. It's still not most of the room, so thankfully my talk has value. So that's good. But quick check and Scala check is really wonderful because it sort of frees us from this problem of having to come up with golden data sets and figuring out what the exact value should be. It sort of flips the problem on its head a bit, and it asks us, like, what are the invariants we can write about our program? And it'll automatically generate data and try and find some data which, when we process, violates one of our constraints. So a really simple one would be, this map of the length, I shouldn't be changing the number of elements in my RDD. Now this is kind of a trivial property, but we could think of something like much more reasonable. We could say like, if I have non-empty strings coming in, the number of tokens from my tokenizer should be positive. And essentially we can use this gen RDD along with case classes or whatever it is we need to generate inside of our RDD, and Scala check will generate these really massive data sets for us. And we can also tell it how much massive data we want it to generate for us, right? Like if you only got a 5-node test cluster, you can be like, whoa, no, it's cool. 200,000 records is fine. And it'll generate these data sets for us. And then once it's found something where it violates one of our constraints, it'll automatically try and narrow down this like really nasty problem to something that's small and we can actually like look at as a developer. Now, admittedly, if our problem only shows up over a certain number of rows, it doesn't do a really great job of like figuring that out super well. But you'll just be like, okay, so this problem only happens when I have so many records I can't print it to my screen. I'm doing something funky here. Like I need to be looking at what's happening at scale. Right, so SSCheck could be used to do this as well. The syntax I showed was for Spark testing base, but SSCheck also supports generating D streams as well as RDDs. The only constraint with SSCheck is that it only supports generating sort of local size data, which isn't the end of the world, but I think it's useful to actually test our things on beyond local scope data. And Spark testing base also does this generating of pathological RDDs, and by that I mean things where we've got empty partitions and sort of weird cases like that, because one of the things that I've done sometimes is written a map partitions where I assumed every one of my partitions had data, and then when I wrote my local tests, everything was fine, but then when I ran on the cluster, it turned out, I actually do have some of these weird partitions, especially after I've done some filtering or whatever. Yeah. Cool. So testing streaming is this whole other beast entirely. It's like Mordor or whatever. And I'm not saying that streaming is bad. I'm just saying that testing it is really challenging right now. Setting up just like a basic stream requires several slides worth of code. And I don't need you to read these slides. I just want you to believe me when I tell you that this code is required. And so it actually works better for me if you don't read these slides. So that's great. But sort of like the things that we need to do is we need to like come up with our own test input stream. We need to create a manual clock so we can sort of override Spark Streaming's sense of time and get an idea of when our test is going to finish. And we also need to figure out like how to collect our results back so that we can actually compare them and see if they were what we were expecting. And yeah, here's the clock. So here's the pandas that I promised, and we're going to test the happy panda way. So QStream used to work prior to 141, and I guess work is a strong word. It used to sort of work prior to 141, but it really doesn't work post 141. So creating our test data is really challenging. Bringing the data back to compare is pretty challenging too, or not so much challenging as ugly. I don't like vars in my code because I'm a functional programming nerd. And if you are also a functional programming nerd, you want someone to hide all of the mutability for you. So we'll do that. And figuring out when our test is done is actually really the hardest part. Even if you look inside of Spark's own tests, inside of PySpark, it has this wait. And it's essentially like doing a sleep, waiting for the test to finish. And that just makes me, as a developer, like cry. And we don't ever want to have our code saying like, yeah, sometime within 5 minutes my test should finish. Because like either that's going to be a really flaky test, or we're just going to like, anyways, it's going to be bad. It's going to be really flaky, or we're going to waste a lot of time. And we really shouldn't be doing that. But we can sort of just like hide this giant mess of code, right? And we can just have this really, really nice test operation. And this is only a local collection, but it lets us test streaming as easily as if we were testing just regular Spark. So I think it's pretty cool. And we can just have this really nice test operation here. And just to be clear, the tokenize underscore for people who are maybe coming from Java syntax, that's just the function that I'm testing. So we could be passing in any function which takes a dstream and returns a dstream. Data frames, we also want to test those, and data sets too. Inside of Spark, there's check answers, which works on rows. And so for Spark testing base, I made similar APIs as the internal ones, except they work on data frames. So we can give our expected value as a data frame. Same thing for data sets. The types should both be U down on the bottom rather than U and V, but pretend that that's correct. I should have edited this slide earlier, but best laid plans. Anyways, so we have this really nice check answers, and we can just assert that our two data frames are the same. And our test looks like this. It's a little ugly. We have this weird import, but if anyone has like a copious amount of spare time and really likes copying, pasting, and editing code from Spark into open source, sorry, not that Spark isn't open source, from Spark into a public project, I'd love to chat with you about sort of the thing we could do so that we don't have to do this weird import implicits. And it's just like this artifact of how some of the implicit conversions are defined. And there's some hacks inside of Spark, but they're not public, so we can't use them. And the cool thing is these tests actually support large data, right? So we can work on data frames, and we don't have to be worried about bringing it back locally. These are actually distributed comparisons for us. We don't have to do anything special. That being said, these tests have been running on local mode. Local mode doesn't work for large data, so we just need to use a real cluster. The easiest thing is if you just have a standing test cluster you can point your tests at, just do that. You can just override the master in your tests, and the shared Spark context will get pointed to your existing cluster. If you're really adventurous, you can use something else. Yarn mini cluster won't give you a real distributed cluster, but it looks kind of more like a distributed cluster if you squint at it after a few too many Bud Light Limes, and you use it after Spark 1.6, because it doesn't really work before then. I'm going to pretty much skip validation for today. There's some really cool things in validation. And if you're interested, Spark Validator has some cool stuff going on. And if there's a Spark committer in the room with some spare time who really wants to take a look at Spark-12469, you would be my BFF until my next pull request. And yeah, anyways. But we'll skip validation. If you're interested in it, check out my project, but keep in mind it's very early stage. There's a bunch of really cool related talks. I don't make any money on those, so I'm going to tell you about related books. I'm a co-author of many of these books, and I think even the ones where I wasn't the co-author are very good books. So that's cool. And there's some new books coming soon, too, including High Performance Spark. And if you really want spam from me, you can go to highperformancespark.com and give me your email address, and I will get in touch with you selectively once the book is available for purchase. And so there's a lot of stuff in there about sort of scaling Spark, and there's some stuff on testing, because testing is really important, especially as we're refactoring our code to make it more performant. And I think I'm probably out of time. This is the last of our packages. You can find this, of course, from the rest of the slides. And if anyone is like, oh man, I really want to use these classes today, here are the Maven/SBT coordinates, and you can add them to your project and start making better tests right now. And you can come to my office hours and bug me with all of your questions about why your tests aren't working. Yeah, we'll just skip to my office hours. So in Concourse F from 2 to 3, and if you notice those earlier sort of pie charts, there's a survey that I used for those pie charts, and if you want my next testing talk to have even more sample data points, you can give me your data. And there will be a Strata presentation pretty soon with a bit more detail on the validation side. So thank you so much, everyone. You're all awesome.
Perfect. If you have any questions, please raise your hand, and I will try to hobble to you so you can use the mic. Questions, anybody?
That's cool. We good.
No? Oh, there. Perfect.
Thanks. Any tips for making Spark tests run faster?
Yeah, that's a really good question. So for making Spark tests run faster, I think using a shared Spark context is like the first obvious quick starting point. There's also, inside of Spark, there's a lot of places, if you're working in PySpark, where they parallelize the tests. And I think that can be really useful. It is a bit of a pain to set up, but if you're at the point where your Spark tests are getting slow, running a lot of them in parallel is pretty good because there's a lot of just like busy wait time involved in sort of submitting jobs and all this stuff. So your CPU is not fully utilized, and you could just really easily parallelize your, well, you could really difficultly parallelize your tests and get some performance benefits out of that and have your tests run faster. Are you doing, which components are you working with? Like ML libs, streaming? Okay, GraphX. That's a really good question. I haven't written a lot of GraphX tests, so I don't have a lot of specific advice for that. But if you want to shoot me an email, we can look at your tests and figure out like what we could do to get them run faster. Awesome.
Cool. Any other questions? All right. Well, then, thanks very much. Appreciate your time.